We are live. Okay, so here we go. Today's date is November 22. 22. So our objective today is to talk about two things. We want to talk about inverse variation. So our graph that we just looked at is an inverse variation. It's like this. As one value gets big, the other gets small. Okay, all right, write that down. And let's look at the graph we just did, okay? Alonzo, did I give you my graph so you can look at it? What's that? Did you look at yours? All right. Now mine is around here somewhere, right? Okay. So what we looked at was this. Check it out. Watch this. As the numbers got bigger on the x, the y's got smaller, didn't they? Or as the numbers on the y got bigger, the x's got smaller. See how that works? It's inverse. As one gets big, the other gets small. As the other one gets big, the other one gets small. That's an inverse variation. Now, direct variation is where if one gets big, the other gets big. And we've seen those. So a line like this, that's a direct variation. So direct variation is kind of like our y equals mx plus 0, okay? They like this symbol k, but to be a direct variation has to be, write this down, must be straight. And it has to go through the origin, which is the point 0, 0, okay? That's direct variation. Okay, so I think this will make sense. When you think about this, as x is getting bigger, so is y, right? That's direct variation. Or an example, if you're little, as you get older, you grow. One goes up and the other goes up. Does that make sense, right? So that's direct variation. As one gets bigger, the other gets bigger. Yeah, just go.
Why does that have to be the origin?
It has to go through the origin, which would be a direct variation, okay? And we're going to learn in story problems why it has to be, okay? Because you don't want to start anywhere else but 0, 0. Good question, really good question. Now, inverse variation is like our graph, right? As one gets big, the other gets small, but the equation we want to use is x times y equals some number. We call it k, and that k is just some number. It's just a number. And they call it, the book likes to call it the constant of variation. Fancy word, but who cares? We got notes, right? So in my example, 24 was the constant of variation. Does that make sense? 24 is the number, okay? So x times y, and those graphs we saw look like this. Right? That's an inverse variation graph, okay? We had, as an example, we had x times y equals 24. That was our example, okay? Now, if we had more time, which, we're right on time, I would have had to do multiples of negative 24. And don't do this, but the only difference is exact same shape, except you'd have a positive and a negative. So it would be here and here. We didn't do it, but the graph would be here and here because you'd have a positive times a negative, or a negative times a positive. Does that make sense why it'd be here and here? Same graph, but if your constant of variation is negative, you'd be in quadrants 2 or quadrants 4. in this graph, you're in quadrants 1 and quadrants 3. Yeah, okay, that makes sense. We're good to go. So, example 1. Determine if it's inverse direct or direct variation or neither. So take a look at example 1. Does it look like that or that? Which one does it look like? This example, which one does it look like? The second one, inverse, and it is. So this one's an inverse variation. Because it's x times y equals a number, okay? Thumbs up on that. Looks just like this, doesn't it? Looks just like this, okay? Good. All right, and then example 2. Well, if I solve for y, I'm going to do this first. I'm going to go, all right, if I go minus x, I'm going to have y equals a negative x plus 0. Does it look like one of these two? Top one, doesn't it, right? So this one's got to be a direct variation. Now before we do number 3, before we do this one, I want you to look at my example here. If I were to solve for y, it could have been y is equal to 24 divided by x. These are the same equation, aren't they? Aren't they the same equation? You just divide by x, divide by x. So that means this could also be a y equals some k over x. And it matches up with this one. Or if I multiply both sides by x, don't want to confuse you, so much just see it. If I multiply this side by x, multiply by x, I could have rewritten it as my x times y equals 5, so it is the same as my indirect variation, okay? Indirect variation, or inverse variation. I'll use both words, or inverse. I use both words. Same thing in math. Okay, example 4. Well, I don't know. Let's see. I'm going to try and solve for x. So I'm going to solve for y first. Solve for y. I got to solve for y. Let's see. I'm going to go minus 4. Minus 4. I'll have an x minus 4 equals a 2y. You okay with that? Right? Solve. Minus 4, minus 4. Divide by 2. Divide by 2. Let's see. That's going to be like a y equals like a 1/2 x minus 2. All right. All right. Which one does it look like? Which one does it look like? Which one does it look like? It's neither, isn't it? It's because of that darn minus 2, so it's neither. I mean, it's not an x, y equals some number. It's not a y equals some mx plus 0. It's a mx plus negative 2, so it's neither. All right, now, 5 is a little tricky, but if I multiply, let me rewrite this, y over 4x equals 12, okay? I'm just going to rewrite it that way. It's just easier to see it that way. I'm not very good at typing up these things because I'm not very good at typing, but if I solve for y again, multiply by 4x, let's see, I'd have a y equals a 48x. Okay, which one do you think this one is? Is it the first one or the second one? 48x, which one? First one, right? It is first one, so this one's going to be direct variation. So they're a little tricky. The trick is to try and put them in either this form or this form, right? You might have to move some things around. Yeah, we can do that. Okay, we turn the page. Okay. All right, example 6. Well, I got a chart, and probably what might be easiest for me is to graph it, okay? All right, so I'm going to graph this one. Put my graph down. Let's see. I'm going to go with something like this. X's are going to be like 2. I'll go by 2s. 2, 4, I'm really messing up. 2, 4, 6, 8, 10. I'll probably go by tens because I got to go to the 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, I don't know what it looks like, but if I can graph it, I can see it. Is it going to look like one of these, or is it going to look like one of these? I don't know, but let me graph it and see. Is it going to look like this, or like this? I don't know. Let's see. 2, 4 is about there. 4, 16 is about there. 6, 36 is about there. 8, 64 is about, let's see, 20, 40, 50, 60, 64, and 10, and 100 is there. That's weird. Does it look straight?
No.
Does it look like one of these? No, I don't think it looks like either one.
Neither.
In fact, these numbers look pretty suspicious to me. 4, 16, 36, 64. What do you know about? Do you know anything about? What about these numbers? Huh? What are these?
Well, they're all factors of 4 except the 100.
Anybody see what these numbers are? I haven't heard it yet. What are they? Oh my God! There, somebody's got it. See? They are squares, aren't this? So this equation's y equals x squared, but that's neither, isn't it? Right? That's neither. So this one's neither. Good job, Blaze. So it's neither. How about this one? Let's see about 7. I'll try and graph 7, see if 7 looks like anything it should look like. All right. All right, I'm going to go. Oh, let's see. I got to get to 50, so I'll go 10, 20, 30, 40, 50, because those are my x's, and my y's, shoot. All right, here's 10. It doesn't go much bigger than that. I got 1 and 5. Let's see, 1 and 5 is about there. I got 5 and 1 is about there. I got 8 and 0.625 is, ooh, this looks weird. I don't know.
Neither.
But let me ask you a question. What's this times this? What's 1 times 5?
5.
What's 5 times 1?
5.
Ah, you got a calculator. Good. What's 8 times 0.625?
I don't know. 5.
Oh, what's 20 times 0.25?
5.
What's 50 times 0.1?
5.
So isn't it x times y?
Equals 5.
Hey, so what kind is that? Is that inverse? Because that graph wasn't doing it for me. You guys agree? But we saw it. That is inverse. Tricky, huh? Okay, now, a little bit of a word problem, but not hard. X varies inversely with y. So we're going to go x, y equals some number, okay? All right. Why am I doing that? Because if it varies inversely, I'm going to go x, y equals some number, okay? So I'm doing that right with that, okay? Now, here's what I know. When x is 2, so I'm going to put 2 in for x, and y is -3, then I can find that value of k, can't I? Well, that's easy. It's just -6, right? So I did this. X varies inversely with y. Okay, so I find my equation. Okay, there's a question, right? So I find it. I'm using that equation, right? I plug in 2, I plug in -3, and so I know k is -6. So now I've got an equation. X times y equals -6. Okay, see what I did? I found it. I needed to find that number. We had x times y equals 24. This one's x times y equals -6, right? Does that make sense? Good to go? Good, we have the equation. Now let's use the equation. What's the next question? There's something else to ask. It says, well, find y when x is 12. So if I put 12 there, go 12 times y equals -6. Let's solve for y. Solve for y? Divide by 12, and I get -1. I'm going to reduce -1/2. You okay with that? Okay, homework today, and this is a short homework assignment. You'll like it. Let's see, where are my notes? So I get the right homework assignment. No, that's not my notes. Here's my notes. Got my notes right here. Okay. Page 172, 1 to 18. It sounds like a lot, but it's not. It really is pretty short. Let's get started on this right now, okay? Right now,